So this is a question 46 in GATE 2014 and set 2. The question says a suspension of sand-like particle in water with particles of diameter 0.01 mm and below is flowing in a settling tank at 0.10 meter cube per second. Assuming G is 9.8 meter per second square, specific gravity of particle is 2.65 and kinematic viscosity of water is 1.0105 to 10 minus 2 centimeter square. And the minimum surface area required for the settling tank to remove the particle size of 0.06 mm and above with 100% efficiency. Okay, so based on the question, we understood that it is a question. It is a question that is based on the settling velocity of the particle. So now the first we will write the given data what the questions have given. So here they have mentioned discharge flow rate is 0.1 meter cube per second. This is a flow rate. Okay. Now they have given the particle size as 0. To remove the particle size as 0.06 mm and above. Okay. So kinematic viscosity they have given as 1.1.0105 into 10 to minus 2 centimeter square per second. Okay. Now with particles around below settling flowing in a settling tank. Okay. So the minimum surface area required to satellite to remove particles of this size. So we know that the overflow rate is equals to Q by A. For 100% roll efficiency, the overflow rate should be less than or equal to settling velocity. Okay, settling velocity of 0.06 mm particle. Okay, so for 100% removal, since the question asks for and above with 100% for 100% overflow rate should be less than or equal to settling velocity of 0.06 mm particle. Okay, now we can write like this as Q by A should be less than equal to Vs. Okay, now we can also write like this as Q by Vs should be less than or equal to, so this thing we can write if we shift to A this side and B here, so we can write like this: A area should be greater than equal to Q by Vs. Now after knowing this thing, we know the value of flow rate. They have mentioned in the question. We have to calculate the Vs. So for Vs is equals to, the we know this expression of Vs 18 mu. From here, if we write like this, we can also write this as Gs minus 1 rho W Gd square by 18 mu. Now we can also write at there Gs minus 1 Gd square by 18 mu kinematic. Okay. So this is now in mu kinematic, but in this expression, this is mu dynamic, but here it is mu kinematic. So using this expression, we will calculate the value of Vs. So now Vs is equals to 2.65 minus 1 into 9.81. The diameter is given at 0.06 mm. So converted into meter, it is 0.06 10 to minus 3 raised to power square divided by 18 into mu kinematic. In the question they are mentioned as this, but it is in centimeter square, so we have to convert into meter square. So it will be 1.0105 1 into 0.05 okay, into 10 to minus 6 meter square per second. So overall this entire unit will be in meter per second since it is a velocity. So from here we found Vs to be 3.20366 into 10 to minus 3 meter per second. This came out to be Vs. But we have to calculate the area. So for area now, in the previous thing, we have mentioned this form area should be greater than equal to Q by Vs. So, putting in this form, area greater than 0.1 is the 1 meter cube per second is our Q. Vs just now we have calculated 3.20366 into 10 ratio minus 3 meter per second. So, area will come out to be 31.214 meter square. So A minimum will be 31.214 meter square. So based on the question, our minimum area we have calculated with 31.214 meter square.